For the longest time, we all kind of thought that our brains were basically set in stone after a certain age, right? That the wiring was done and that was that. Well, it turns out that's not true at all. Science has shown us something truly incredible. Our brains are constantly, and I mean constantly, changing throughout our entire lives. So let's dive into this amazing world of neuroplasticity. So here's our game plan. We'll kick things off by defining what neuroplasticity actually is. Then, we'll look at the brain's toolkit, how it makes these changes. After that, we'll get into how this can be both a good and a bad thing. We'll take a peek into the future of brain health, and finally, we're going to tackle some of the really tough ethical questions that all this new science brings up.
All right, let's start with the big central idea here. The old myth was that the adult brain was static, that it didn't change. We now know that's completely 100% wrong. Your brain is a dynamic, living, and constantly evolving structure.
To put it simply, neuroplasticity is just the brain's incredible ability to rewire itself. Seriously, every single time you learn a new skill, form a memory, or even recover from an injury, that's neuroplasticity in action. It is the very engine of learning and adaptation.
But here's a really crucial point, and it's a theme we're going to keep coming back to. This amazing power to change isn't always a good thing. As researchers Allred and Jones put it, it's a double-edged sword. It's a force that can build us up, but it can also lock us into some really harmful patterns.
So how does the brain actually pull this off? Well, it's not magic, it's just biology. And the brain has a specific set of tools that it uses to perform these, honestly remarkable feats of self-reorganization.
The brain has 4 main tools in its toolkit, and don't worry, the names might sound complex, but the ideas behind them are pretty straightforward. We're talking about changes at the connection points between neurons, physical changes to the brain cells themselves, the birth of brand new neurons, and even a large-scale reshuffling of who does what job. Let's take a look at how these actually work.
Okay, this table here is basically our roadmap for understanding the nuts and bolts of it all. It's fantastic because it connects each of those mechanisms to both its good side and its bad side, and it even points to ways we can intervene. So let's break down a couple of these key rows.
First up, we've got synaptic plasticity. The best way to think about this is like turning the volume up or down on the connections between your brain cells. So when you practice a guitar, for instance, you're strengthening certain connections. That's a process called long-term potentiation, or LTP. But, and this is a big but, that exact same process can go haywire, creating over-strengthened pain circuits that can lead to chronic pain.
Next is structural plasticity, and this one includes the actual birth of new neurons. And right here is where you can see the direct impact of your everyday habits. Regular exercise, it can actually boost the production of new brain cells in a part of your brain called the hippocampus, which is absolutely vital for memory. On the flip side, chronic stress does the exact opposite. It slams the brakes on that production, and that can contribute to things like anxiety and depression.
And finally, there's functional reorganization. This is where the brain literally reassigns jobs. It's incredible. After a stroke damages one part of the brain that controls movement, a nearby area can sometimes learn to take over that function, allowing for recovery. But again, in amputees, this same reorganization can become maladaptive, creating the agonizing sensation of phantom limb pain, basically because the brain's internal map of the body hasn't updated correctly.
And all of this brings us right back to that central theme we mentioned earlier, this idea of neuroplasticity as a double-edged sword. It's wild to think that the very same process that allows for incredible learning and recovery is also the one that can dig the trenches for our worst habits and conditions.
So the positive side of the sword is what we call adaptive plasticity. This is the brain at its absolute best. Learning, building resilience, healing itself. It's what's happening when you study for an exam, when someone recovers from a brain injury, or even when you build up cognitive reserve to protect your brain as you get older.
But then there's the dark side of that sword, maladaptive plasticity. This is where the brain learns the wrong lessons, so to speak. It carves these deep neurological pathways for things like addiction. It reinforces the fear circuits and anxiety. Or, like we just saw, it can get stuck in a vicious cycle of chronic pain. So this leads us to the multi-billion-dollar question, right? Can we actually take control of this process? Can we actively promote the good kind of plasticity and dial down or even reverse the bad kind? Well, the answer is increasingly looking like a yes, and we are right now entering this incredibly exciting new era of essentially hacking the brain. And just look at the incredible toolkit scientists are building to do it. We're talking about brain-computer interfaces that can help stroke patients move again, non-invasive things like transcranial magnetic stimulation or TMS to treat depression, and even looking at gene editing technologies to potentially reactivate plasticity in aging brains. The future is pretty wild.
But before we get too carried away with all the sci-fi stuff, it is absolutely crucial that we look at the hard science behind these ideas. And that's what this table does. It shows us the quality of the evidence we currently have. Some things, like using TMS for depression, have moderate to strong support. But a lot of others, they're still emerging. This really helps ground the hype in reality.
And here's the best part. You don't have to wait for some futuristic tech to come along. Some of the most powerful tools for shaping your own brain are available to you right now, today. Things like consistent sleep, a healthy diet, regular exercise, managing your stress, and just staying socially connected. These are all proven, accessible ways to promote positive neuroplasticity. Of course, as we develop these amazing new abilities to intentionally change the brain, well, that's where things get complicated. We run headfirst into some very serious challenges and ethical questions that we absolutely have to start talking about.
And this table lays out some of the biggest ethical hurdles. I mean, think about it. Who gets access to these potentially life-changing but very expensive technologies? How do we protect the privacy of someone's literal brain data? And where do we draw the line between using these tools for therapy versus using them for cognitive enhancement? That could create a whole new kind of social inequality. These are not easy questions with simple answers.
And on the scientific side of things, we've still got work to do. This table summarizes the gaps really well. We need to standardize how we do research so we can compare results. We need to conduct much longer-term studies to see if these changes actually last. And we need to get way better at personalizing treatments, because one thing we know for sure is that one size does not fit all when it comes to the brain. So, if we bring this all together, the key takeaway is this. Neuroplasticity is real. It's incredibly powerful, and it's happening inside your head right now. But it's not magic. It's a fundamental biological process that we are only just beginning to learn how to consciously guide. And doing that requires balancing our immense optimism with some real scientific caution and ethical awareness.
And that leaves us with one last really profound question to think about. This technology isn't just about fixing what's broken. It's about shaping who we fundamentally are. As we gain the power to literally reshape our own minds, the biggest challenge of all might not be a scientific one, but a human one. Deciding what kind of people and what kind of society we truly want to become.